Okay, well, let us talk about spatial filtering. Some initial part I talked before, uh, but again, because I wanted to continue for this type of filter, I thought that maybe again we can review it and then it will be more beneficial for us. As we say, we have two type of filtering which will be applied on our image. One will be the spatial domain filtering, and another one will be the frequency domain one, which for the spatial domain filtering, we are performing the filtering operation directly on the pixel on an image. And we can call this technique, uh, which is based on the pixel and neighbors to select a new value for the pixel. Um, One of the simplest form for this type of filtering is linear filtering, as we discussed in theoretical part, which in that it attached the weight to the pixel in the neighborhoods of the pixel of interest. And these weights are used to blend those pixels together to provide a new value for the pixel interest. Linear filtering can be used to smooth, blur, sharper, or find the edge of an image. And as I showed the four picture here, which the upper left hand corner is the original image, and rest of them are the special filtering job which we put on the image. You know that sometimes a linear filter is not enough to solve the particular problem, but in that case, it's possible to use some higher order maths to flow down, and the MATLAB function have these jobs that it can you, uh, do this special filtering for the part which is not uh, sufficient. Okay, before starting that, let us first review again some more things about the uh, working with MATLAB function. And I think let me share my desktop with you, which we can work on the MATLAB. Okay, hold on. The first thing that we will do, that is the adjacent image intensity for color map or any other map. That was one function that we learn, and we know that in im adjust we have some parameter like I, low in, high, uh, low out, high out. These are the formats, and based on this you can adjust the intensity of your image. As I said, the one of the maybe nice and initial work that you will do on image processing, and not all the time, but most of the time, we are going to tune or this intensity or image intensity part. Here, this is one of the application that you can see how to do it. What I forget before this code is this CLC and clear all, and then close all. Even there is not much more things after my means that my MATLAB is just already run. But anyway, no problem. Try to have this habit, which will help you to see the proper value or proper result from your recent work. Okay, I run it now. I'm waiting for the result. I'm waiting to see the effect of high in between 0 to 1 at the first picture, and then high low of it of 1 to 0. And then based on the formula, I mean this formula that we have or the function that we have, uh, low in, high in, low out, high out means that between in and out, I'm waiting for the value intensity which will be generated. Okay, the pictures are come out. We can see here now the result of the code that we made. Let me put them together. And then actually the better method or better way to show all this is using the subplot. But as uh, I didn't do it with some purpose, but maybe if that was all of them was in subplot, that was it. Now you will see the intensity is changed, and we work on that based on the different value. But which value now you can see? This is the original rice image. We will keep it out. Okay. But next one, between 0 to 1, we put the high and low value of in and out, as you will see. The rest one, we put the zero point 0.5, and the last one, we put the 5 as the intensity, and you will see that all are changed in this sample image. Yeah. Let us think like this, that if you want to do any process on the image, you should have some box before that. And really, this is like the box, means that all the activity that we will do, it's really like the box. Uh, it means that with these boxes, uh, we have some process of work, which that is why they call it pre-processing. Okay, something or some job that you will do before the main analyzation or main activity on your image. We call it pre-processing. This part for the intensity value is, we can call it one of the um, initial, and somehow it's a fixed intensity job, as we call it as the pre-processing job. Okay. Next thing which is more important is that showing the different histogram image that maybe last time I didn't show it for you. Let us do one thing. First, I will again open this rice with the histogram, but after that, we will check the value of changed intensity of histogram on each image. Means that mixture between program 1 and program 2. Just program 1, program 2 that I show you here, it's the different form of the uh, histogram, which, which now I can tell you the number 1 somehow it's better for us because it will show the range. Okay. Now with this number 1 uh, demo means that I am hist of f. What we will do, we are going to mix that both program together, and then maybe this uh, adjacent function will come to picture and can show us maybe the better uh, analyzation about our, yes. Okay, what I have done here, I put image I'm hist of the I'm hist of the image means that real image. Then I will call next one as G1. I'm hist of G1. Again, I will do H3 as G1 of G2, and G4 H4, which we call it as the G3. Okay, first thing. what I want to show that, I want to show it like this. F1, F2, F3 as the uh, intensity value, then it should be image 5, and then we can now have the image 6 as the I'm hist of H2, and then now we will continue for H3, 7, and 8. Now we are expected to have the 8 image, which in all our aim is, okay, let me do it like this. Yes, maybe this image part can be here. Yes. See, this close always remain from previous code. If I do it like this, then it may have the error for me. Now what I have one part which show the intensity and another image which shows the histogram of that. What I mean, I want to show you that what will happen when we tune the intensity of the image. Let us run this code that already we mix it with the previous one. Image 1, image 2, 3, 4. These are the image intensity. Now we are waiting for histogram. Okay, it's come. Now you will see what will happen. Nothing is good. Okay. Okay, let me check once more. I am hist of FH2O. No, that is wrong then. See what we have done. We should not do the H2. We should do on the like this. See, 2, 3 times I do the I'm hist, and then after I'm hist of F, which F is okay, got it. Yes, this is the problem. I don't know why I made it like that. That is wrong. It should be G1, G2, and G3. You know what I have done? 2 times I showed, I think, the histogram. Let us see that this problem will be solved or not. Yes, 1, 2, 3, 4 as the main image, and now we are waiting for histogram. Histogram 1, 2, 3. Yes, it's coming. Okay, now this is what I wanted to show you. This is the job or the result which may bring some meaningful data for us. See, this picture is related to the image. See how the spectrum or how we have the range of the white and color. See the values. Okay, this is for image 1. Now for image 2 means that we tune in intensity here between 0 1 to 0 0 1 and 1 0. It will become as the image 2, and then this one. Yes, see the value is little bit change here. It's going more than 200. See image 3 and 4. See, it's pushed to the right side because more intensity we have here. And at the last one, which is more darker, What we expected? We expected that it's come to the left side. Now compare. This is the original one somehow. This is the second one actually. This is when intensity means that we have the more dark. This is when we have more bright image. See difference between bright and dark. Even you can see here, it's very near to the zero. It means that it should have more darker, and it's very near to 250, which is very near to. It means that we have more light, more intensity part inside the figure, and maybe what it will show us, it will show us the spectrum of figure number 6, which is related to second image. I mean the value that we will put for the here. This one, it has the better spectrum. Why I say? Because most of the numbers now, I have the numbers here, but for these two cases, I push it to the right or I push it to the left. Then remember this job. When you will do any intensity job or any process on your image, you should avoid the work in the sense that you should not lose any information. Okay, this code was nice. I think maybe we can add it uh, inside our PPT that you also can enjoy it afterwards and have the better analyzation for that. That was the beauty of tuning the intensity or finding the intensity, which, my friend, it will be the one of the maybe good job or one of the somehow it may be the one of the difficult job for a person uh, with finding which intensity value is proper. It may different between the image and some auto detecting. It can be somehow a good job or some good algorithm. Okay, that was one job that we have done. Let us do the OSTO method, which already I give you one example and you saw it. Which one of the method to find a good threshold in the grayish uh, picture. And in this method, the aim is to find the proper threshold or minimize the interactless values in the binary image. Let us check these on our cameraman image. Let us see. Yes. And we will do the some job like this copy paste. We should remember that somehow some value can be changed in our work. Okay, well, let us see the code, which is not different, just difficult. What I have done, I open the image, then I put the gray trash, uh, and then I change it to the binary and then show the level. Let us see here. Okay, but which level we have? We have 0.3451, which is proper. Why now it's nice, this job? Because as you can see, if my aim is finding this cameraman, I can do it very fast here. Think that suppose my job is to detect this person. Please think for this part because Reza is also today will do some part which is very near to the talk that we have. That is why I'm happy with his today talk. Suppose uh, I want to count the rice. in this image. See what the difference between this result and the uh, other intensity job that we have done. Simply now I can, with some shape detection or with edge detection algorithm, I can count the rise much more simpler than the original image that I have. Can you see now this? Then this job is also is one of the good things to show the review, to show the uh, I mean the threshold value of the great fish image. Okay, let's go for one more things. Maybe on this cameraman. Now we can do one more job. Let me copy paste this. Yes. This I don't like. This I don't like. What I will do, I will show the cameraman, and then I show the histogram of that. Um, is the original one, and then I, with the help of IM hist, which in this IM hist we use the histogram equalization. Means that now we are searching to see how we can equalize them. Okay, let us first show this program. Then I have some talk on that. Yes, figure 1 and figure 2. See the equalization. Obviously, you can see that the number 4 is spread out between 0 to 250, and number 3 is somehow it's centralized or will be in the some part. Number 3 is for the original one, and number 4 is for the equalized one. Now, what we will do, let us show the gray means that hist for this gray colored one. Let's see that this code is working or not. Means that what I'm going to equalize the cameraman picture. Okay, I defined. Oh, okay. We read this cameraman as F before. Now we should do it as again F. Let's go. Okay. Oh, why I become this much? See what will happen. It kill the image. This is the grayish things that we have done. Totally, we could remove. That is what I wanted you to see. Totally, we could remove the background. See the difference? Background is gone. Now this person become bold, and you can do it. You can find it better. It may be one application or at least one good practice that you can do based on this image and what we can say, working to remove the background. Okay. Okay. Now let us enter for the filter part, which is the aim of main aim for today lecture that we have. Remove. Okay. Now we will start with again this rice image. Okay, that is the image that we have. We have some predefined filter. The first one is the motion blur. That now let us see the result. Yes, it's motion blur one with the value of 20 and 45. If I want to show the sharpening one, okay, now you will see that it's become little bit head from the background again. Horizontal edge detection job, which in that here, can you see the edge for the rise is counted here and it's become blur. These are the predefined filter that we can have, and we can use it on different image job. Uh, then for the image filtering correlation, let us have this example, but I should, I think, furnish this example better. In this example, you can see the various filtering which we can have and do the coding in the image processing toolbox. The output will be three image, which in that we will see the uh, some feature of the IM filter uh, function. Then after this, we will see the IM filter correlation. Okay, filter one, filter two, filter three. What will happen with this image, as you will see, is that in correlation part for the last image, the image is little bit up and down. For the second one, what will happen if we compare with the first image or original image? We have some problem with the bottom side of image. For the first one also, we are working with this part, as you will see. Okay, but let us see what is the act or what is the use for this IM filter function. Simply, I open the help of the MATLAB, which in that we can see. Okay, little bit my MATLAB is slow. Okay, IM filter is ND filtering for multi-dimensional image, and in this, even you can see the various job that we have done on the image, and we review this once more. But it can have lots of input, okay, which will affect these filtering job, or all these filtering job will help us to do that pre-processing job. Suppose with the symmetric one, input array value outside the bounds of array are computed by mirror reflecting. This is what we had there. We had some reflecting of that. Suppose we replicate input array values outside the bounds of the array are assumed to equal to the nearest array border value. And with circular input array values outside the bound are computes by the implicitly assuming the inputs array. This is what we assume for this uh, function. What I will do, I maybe it's not bad to put this short description inside our PPT, and then when you are going to review it, maybe you can also use these. Let me put this for our PPT part. Then it may help you to understand this program maybe better. And then by this you can learn more about today's lecture. Okay, I will put it here, but anyway, If you wanted to uh, have the better analyzation for this code, simply you can do the same job that I have done, means that you can do the help and analyze the code. This is one thing that I can I advise you to do it. Don't just copy paste the example. Try to do the help job for them. And as suppose the previous task that I like it, some of you work very nice on the function that we had in our lecture series till now. Again, we have, you know, and then at the end of this course, I expected a nice list, which in that you can see the some major image processing uh, command. Okay, let us see for the spatial filtering, mean the Gaussian part, how we can act on our again cameraman image. We can use this. Okay, let me close and run this. What I have done, I use the IM noise function here, and now I will show the noisy image, smoothing image, and original image here, which all this process also can help me to have the analyzation. You will see that for the smoothing image, what will happen? The curve and uh, outside of my image little bit it's become blur. For noisy, it's add the noise for me, and the original image is there as the output for my uh, image. One function which is nice and we have is f special. We have the this format f special with the types and parameters. Which in parameter part type part you can have the average, you can have disk, you can have Gaussian, Laplacian, log, motion, and Sobel and on-sharp and sharp, something like that. This is also one of the good filter that we can use on our image. Let us test this example or this function on the same example, this poor cameraman that we have, and then let us see how you are going to kill this photo. Okay, now you will see. The first one is my real image. Second one is motion blur, and last one is the blur one. You will see that really the image become useless somehow. If our target is that we want to find the person there, okay. But if maybe you have another application, then it will be suitable for that. But currently, if your target is finding that person, it's not working proper. Go ahead and do the rest feature that we have in f special function with the different value and different parameter here. Yes, you can see here motion blurred image, sharpened image. See the sharpened one and original one, which I show all of them in this subplot. Actually, showing maybe like this will be more informative for you to see. But main thing is that become picture become small. I rarely use this part, but because previous example we show already the effect of a special. That is why I put them in the subplot form. Okay, let us go ahead and work more with this function. Means that intensity transform and special functioning. We can have one example again with the sharpened one and Laplacian one. It's a little bit repeated the last work, but now just I add the Laplacian one, you will see the effect on the image. What nice thing it has done, it's clear for me the edge or any edge of the image here. The work of this function is that it can help me again to detect this person. Work more on our image is that this cameraman with noisy image, median filtering, and original image, which now we can compare them here. See, noisy one and median filtering, which it will add some dots and some not proper, we can say, images happening here. Um, yes, see the other type of the filtering part with I mean the frequency domain now processing job. It's this part is related to our segmentation lecture that we had before. From now, these are the segmentation methods. See, log transform, inverse FFT. Yes, you can see FFT shift, inverse FFT. FFT means that Fourier transform, an original image, which effect we have here, and we discuss in our theoretical lecture about them. Go more about frequency domain one, horizontal filtering in frequency, vertical filtering in frequency, mask, which we can see in this example. Yes. Now you can see the Sobel filtering in a spatial domain and Sobel filtering in frequency domain. See the difference. This is nice. Little bit with the frequency domain for this specific picture working better, and it's make it out. Is that the edge become more clear for us. And for the first today lecture, I think it will be the last slide, which again, with the help of cameraman picture, we are going to work on the GLPF value with different value and effect of that. Okay. Your task for first part is that analyze this uh, last image and send your analyzation. Then the one task for today is this, that you should analyze the example number 14 of this today lecture for the next one. I want you tell me what will happen when I change the GLPF. First of all, tell me what is GLPF and how it will affect. What should be the result of this image? As we discuss, we actually finished some theoretical part regarding our subject, digital image processing subject. Some activity now will remain, which is how we can implement them inside the MATLAB, how we can have the better view for this theoretical part that we read. We will have some example regarding the edge detection and half transform. I think around 14 example I prepare for you again, and finding these codes and have the proper code with the aim of our lecture. Little bit it's take time, but no problem. It's our syllabus and my special duty. Then please, if you have any problem with the codes, you can ask me, but please check your MATLAB installation, check your codes, check everything, then inform me. And be sure that all results I test one by one and put the screenshots here. Okay. as you see, the screenshot that you can see inside the PPT is based on what I will implement. And the aim of implementing the code in the lecture is that you have the better uh, view and better practice. Now, with this condition, we cannot test on our system face to face, but maybe one method that we can have is that I run each code in the lecture. It takes time, but no problem. We are I think now we are in the good position for syllabus and time and all. Okay, first of all, let us see and review some ports regarding the edge detection. You know, in image processing, the extraction of the feature from image is one of the common problems. Over the years, several different approaches have been devised to exact this feature. And these different approaches can be characterized and classified in some different ways. Some of technique involve the global examination of the image, while others only work on the some local examination of each pixel in the image. In this concept means that finding the image, typically the first step is to perform some form of the image detection on the image, and they generate the new binary edge image that provide the necessary segmentation of original image. Edge detection algorithm will operate on premise that each pixel in the grayscale image has the first derivative with regard to the change in the intensity at point. Then what we know as the edge is the difference between intensity. Now, maybe some of you will have this in your mind that okay, that is why I tell you adjusting the intensity in the image will be the nice job or some pre-processing job for any image processing um, algorithm. Then this difference of intensity at any point, if a significant change occur on that at the given pixel in image, while pixel is placed in the binary image, otherwise a black pixel is placed there instead, all will become as the concept of edge. Then edge, or in the other words, border is the difference between black and white, or but one big different or one bold value of the image matrix will create the image create the edge for us. Remember this in your mind that what we call edge is nothing but border in our image. In general, the gradient is calculated for each pixel that gives the degree of change at that point in the image. And the question basically amount to how much change in the intensity should be required in order to constitute an edge feature in the binary image. Then some jobs that we have done on that cameraman in the first lecture was regarding to this question, that how much I should increase my intensity. There is not exact answer to this, and what I think that it's mainly based on the application and nature and type of the image and your aim in image, what you are searching, what is the target of image processing for you. And the threshold value, which always we call it as the T, is often used to classify the edge point. And some edge pointing techniques calculate the second derivative to more accurately find points that correspond to the local maximum or minimum in the first derivative. This technique is often to refer as the zero crossing because Local maxima and minima are the place where the second derivative equals 0 and its left and right neighbors are non-zero with opposite sign. Edge detection with the edge function in MATLAB will be represented, and the image processing toolbox edge function provide several derivative estimator based on the criteria just you learned about. And for some these estimator, it's possible to specify whether the edge detector is sensitive to horizontal or vertical edge or both. Remember this point. It may help us for future work. The syntax which we use for edge detection is something like that. Edge, F, method, parameters are the parts for this function, which in the edge detection or edge detector part, we have three famous algorithm or method that we know it as the Sobel, as the canny, and as the zero crossing, which let us compare them or see the basic properties of these three famous algorithm. In the Sobel, we will find the edge using the Sobel approximation to the derivative. In the canny, we will find the edge by looking for local maxima of the gradient of fxy, and the gradient is calculated using the derivative of a Gaussian filter. The method uses two thresholds to detect the strong and weak edge and includes the weak edge in the output only if they are connected to the strong edge. Therefore, this method is likely to detect the true weak edge. And let me tell you the truth that this method is one of the most applicable edge detector method which is used, and it's very nice one. I can tell. Zero crossing, it's another method which find the edge by looking for zero crossing after filtering with the user defined filter. And this method is often combined with the Laplacian or Gaussian filter methods. But any filter that approximate the second derivative of image data will do. And if you don't provide your own filter, zero crossing will use the equal of this filter. Something like this. You can see the help for the E special event function from the MATLAB for more information. In the output, G, I mean the output of the main function that I mentioned at the top of my slide, is a global array with first at the location where edge points were detected in the F and zeros elsewhere. And parameter t is optional. It gives the threshold used by edge to determine which gradient value are strong enough to be called edge point. Um, Now let us do the job and do the mm, different method and parameter to see what is the difference between them. Okay, let me again share my screen with you. Is that the desktop? And test all the codes. First of all, we will work with the concept of edge and how we can implement them. Okay, let us see the first code that we have. Okay, what I targeted in this code, or what is the aim of these codes that I have is, wait, hold on, let us do this copy paste job. In these codes, I have some zeros for a matrix of 128 to 128. Oh, three times we have done the copy paste here. And then between that, I will use the Sobel and vertical line to see the output of this. My mistake. Okay. Now it will give me one value as the T1, which what is T1? Based on the analyzation that we have done before. Oh, 1 minute. Good.
Sir, your screen is not visible.
Yes. Got it. Just hold on, please. I will, yes, share a screen, desktop, run. I think now you should see. Even I don't know what it happened to PowerPoint that it's restart once. Okay, good. Thank you. Good. Okay, it means that you didn't sleep in the lecture. It's good point. Okay, now you will see the process also. Yes. Well, we were, I think, for the first example, just yes. Okay, here. As we talk, we have one value of the t, which is as the output of my edge detection function, and it's the gives the threshold used by the edge. Here, what I have done, I see here, please. After running this, I can see the threshold value of 31.93, and I can see the vertical Sobel filter or edge detection job here. Let us test for the next one, then we will see more different here. Yes. Now let us see with the canny and help of the sigma, what should be the T3 value for us. T3 value, it has two value for me because now I have more than one edge. I have four edge here, and I'm use the canny methods to finding the threshold value. As we said that intensity and threshold are two critical parameter that should be clear and defined for this. Okay, one more things that we talked in theoretical part was regarding the Hough transform, which is the robust method for finding the line in the image that was developed by Paul Hough. And the main idea for HT or Hough transform are for each line L, there is the unique line which segmented as S, and this is perpendicular to L, which passes through for origin. This segment can be used to represent a line and is called the Hessian normal from H and F. This n, which is perpendicular, has a unique distance or radius r from the origin and angle theta from the horizontal axis of the image. This angle will show the distance defined a point in a parameter space and sometimes known as half space. Now, what will happen in MATLAB? In MATLAB, the origin is located at point 1, and other system may place the origin at the center of the image or at 0. Then the angle theta only cover 180, sometimes positive, from 0 to 180 are used by the default, but it's between -90 to 90 in MATLAB. Have this information about the HT methods, and remember that a point in image space has some infinite number of lines that could pass through it, and each with the unique distance and angle. This set of line correspond to the sinusoidal function in the parameters space, and 2 points on a line in the image space correspond to two sinusoids with cross at the point in parameter space. That point in parameter space corresponds to that line in image space, and all sinusoids corresponding to points on that line will pass through that point. To implement this algorithm, we quantize the parameter space by using some 2D array of counters, where the array coordinates represent the parameter of the line, and this commonly known as accumulator array. In this method, I mean the HD1, then for finding the line generally consists of this stage. First is accumulate the tracing of the parameter sinusoid for each point in a binary edge map into the accumulator array, and then find the peak value in the accumulator. Then we will verify that the peaks found correspond to the geometric lines rather than noise, and the process will be ended. Let us start to do some work. I mean, first, suppose some line detection with the help of this half transform, which in MATLAB, we have the function of half that computes the HD, and we will illustrate the use of this function in this example that I bring. Uh, Let us do this test and see the result. Okay, but before that, I think some part is missed for this. That yes, first is that I have that zeros matrix here. Then I take the half for that. Then I will show it, and then again we will see how the line will be detected. Let us see the result. I run the program. See, the line is detected. See the crossing part? These two parts, I don't know how much it's visible there in your computer. Is it visible?
Yes, sir.
Yes, sir.
Ah, okay, see that there is two a small part here. I think at this location. See, yes, here and here. This is two locations that you can see the RGB value of 000 and the location. Let's go more for the second example, which is regarding the edge detection with the canny, and see that these are not on the image because first we want to clear and generate the picture with the help of matrix. Means that what I have done in the previous half or HD method is that we generate the image, or as we know, image is nothing but matrix, and then with that we declarate the edge. Now here we do the same job, make the image, and then with that we find the edge. See, these points are the edge which is detected, and you can see them. Maybe these are good for just knowing the application and knowing the working function, but for main task that we have, and that is working on the image, still you should wait for 2 3 slides and then we will continue. Now we know that to do the half transform, the next step is that we should using the peak detection, and in MATLAB we have the half peak function, which in that h is the half transform function, and non-peak is the maximum number of peak location. Something that you should remember, that peak supers other peaks that are close to the peak just detected, and that if peaks are too weak, they will not be detected. This behavior can be controlled by the parameters. And again, if you want to read, you can read half peaks detail from the MATLAB function. Let me check one more example with the half detection, and then you will see the result of detection based on this half method. Okay, okay. Now what I have done, I exactly specify the edge based on HG with the green line on some matrix that I generate. See, these are my borderline, which is detected by HT method. Okay, for line linking, once we set of the candidate peaks that has identified in the half transform, it remains to be determined if there are line segments associated with those peaks, as well as a start and ending point. And for each peak, the first step is to find the location of all non-zero pixel in the image that contributed to that peak and construct line segments based on those pixels. Half line function can do this. And again, for more detail, you can read from the MATLAB uh, function. Okay, I should also see the time for result. Image threshold, you know that it's one of the very important rule in image segmentation. And now we discuss one way of choosing threshold automatically. We can have some algorithm like this that first select an initial estimate for t. A possible initial values is the mean point between the minimum and maximum intensity value in the image. Segments the image using T. This will produce two groups of pixel, G1, which is consisting of all pixel with intensity value greater than T, G2, consisting of pixel with value less than T, and compute the average intensity value x1, x2 for pixel in region G1 and G2, and compute the new threshold value to shift for some real image and see the effect on some papers, PNG picture, and see that how crossovers will work. Okay, now you will see with the zero cross, not crossover, zero crosses, output is like this. You see all the edge are detected, but which method is better? Again, it's depend on the application that we have, nature of pictures, and mode of the image that we can test. Suppose if I want to test on cameraman also, you can see the result or other picture. Let us suppose see Laplacian and edge sharpening example here that on cameraman I have done it. Let us see. Yes. Here also you can see some enhanced one, enhanced image that see the border, which is nicely drawn in this image. And with the other one, again, some edge enhancement job that we have done here. Oh, again, you can see the result here. And because the image are not first converted, okay, something is wrong. Sorry, thing is not copy paste proper. Yes. I think that code is maybe some problem. Okay, I think it's number 9. Yes, here you can see more edge with the Laplacian one. See the blue one, and then you can see the LOG filter, which we inbuilt in that. But for the first order edge detection, maybe this can be the nice example. A little bit, I should talk fast because we have one presentation. Now I use the Robert edge, Poverit edge, Sobel edge, and display them with different. Now suppose you will see the Sobel is very nice. If we use Canny, you will see that Canny will work maybe somehow more effective than others in this image. And suppose if I want to check with the Laplacian uh, edge detection, again you will see that maybe on this image you will not be much more data, even it's detect, but uh, something that we expected is not just to picture. Uh, okay, I think it's maybe the better example, number 13, that will, as I put a comment on the image, I expected that uh, oh, okay. Now one thing happened. I think I do make some part is wrong for my PPT. I should check these codes once more, and then I will share for you. Just you test them. Yeah, I made a mistake while I do the coding part. No problem. Okay, now it's okay. Suppose this one we can say the different image we generate by the Gaussian filter, Gaussian kernels as the filter that we had, and also we can display the unsharp, display the original shape, and you will see the what we can say image output that way. Okay,